All right, so A is your start, and then B is your growth rate. And remember, when I say growth rate, that could be going up or down, could be increase or decrease, right? All right, so now what we need to do is, first of all, we know that that is growth, all right? That's definitely gonna be growth. Because B is greater than 1. All right, so that's the simple part. So it's already selected as growth, but now you need to find the percent increase. So what it means is that from this number, we're going to determine what that increase is. Now, because it's growth, that means that I need to figure out how much more than 1 is this number, all right? And what we're going to do is we're going to take that number, 1.06, and I am going to subtract 1 from it. So I'll subtract 1, and I get 0.06. All right, that's my percent increase. All right, that's my percent increase. Because again, remember, this is growth, so that's my percent increase, but I got to convert it to a percent. In order to convert it to a percent, I am going to move the decimal 2 spaces to the right. So I go 1, 2. So the decimal is after the 6, which makes it a whole number of 6. So the percent increase is 6%. All right, so remember that when you convert, and I'll stop and I'll pause in a second so you guys can catch up. When you convert, move the decimal 2 spaces. Okay? Okay, so now let's see if we can find a problem. First, let's put in 6%. We know it's an increase. Yada, yada, yada. Yay. All right. So, so now here's a decrease. All right. And I know it's a decrease because right away you guys can see that that number inside is less than 1. So what I want to do is first make sure I mark decay. And let's write this out first. All right. So we got, let me zoom out a little bit just in case you guys are still on that last one. All right. So for this example, we got 8,600 as our A. Our B is 0.96. And we know that this is decay or decrease. Because B is, it's greater than 0, but it's less than 1. That's why I put the B in the middle, because it's less than 1, but greater than 0. Now, because this is a decrease, remember that what you're doing when you're looking for that B value is you're trying to figure out how far away is it from 1? How far away is it from 1? So what I'm going to do instead on this time is I'm going to take that number and subtract it from 1. So notice here, before the first time because it was growth, because it was bigger than 1, I subtracted 1. But here, I'm doing 1 minus that number so I can figure out what that number is, okay? So now, let me write that over here. So what you're doing is you're finding the difference from 1. So that's what we're doing here. All right, so in this case, we're doing 1 minus, whereas up here we did minus 1. All right, so I subtract those two, I get 0.04. Now, just like we did before, we're going to convert that by moving the decimal 1, 2. Hold on, let me change it. My marker here. 1, 2. All right, so I move it over. It goes right after the 4, which makes the 4 a whole number. And it's going to be a 4%. Remember, it was decay, so it's actually a 4% decrease. Decrease. All right, 4% decrease. So then I go over here, I put 4%, and it's the decay. Hopefully you get it right, and it's good. Okay, I will. Okay, so let's go on to the next. All right, so yeah, then when you get to this one, you're gonna get a bunch of the same problems. They're just, these ones you gotta start getting right, actually getting them correct in order to pass that one. Okay, so now exponential functions basic. All right, so this is the one, if I'm going back to folder C here, go down here, you're watching this side puzzle about that. Mr. Kershaw goes through that one. And this one, you're given a situation, okay? Now, there's a few things you gotta really pay attention to here. And first of all, figuring out what you're starting with, what's the rate, how much time, because time is gonna be a number you're gonna plug in. And then the fourth thing is we gotta pay attention to what is it asking us to round to? Because there's different types of rounding for every situation. All right, so let's look at this one first. So it says an element with a mass of 490 grams decays by 28.6% per minute. Now, what are we talking about? We're talking about elements. Okay, elements. Periodic table. You guys ever take chemistry at some point? You're going to learn about this. You guys probably recognize this. These are elements, the things that make up our universe. All right, so we have things like carbon and nitrogen and oxygen, which are these ones up here, boron. Some of you guys might know Ag, which is silver. All right, Au right underneath that, gold, platinum. These are all elements that make up our Earth, okay? And if you guys go all the way to the right, those are gases. So maybe you've heard of helium, like when you're blowing up a balloon, right? And then you suck it all in and you go, you know, you have like the funny voice. Okay, that's helium. Now, what happens to those elements is over time, they decay, they break down. It's kind of like when, sadly, you know, your little puppy dies or cat dies and we got to bury him, right? Like the body decays, it breaks down. Okay, elements break down. All right, so that's what this is all about. So anyways, enough science lesson. Let's get into the problem. All right, so we're starting with, we're going to put the details over here to the right. So we're starting with the A value, which is 490 grams of some element. We don't know what the element is, doesn't really matter. All right, then it says that it decays at 26.8. Wait, sorry, did I say 26? 28.6% per minute. All right, and then it says that it wants you to tell, the question is how much will of the element will still be there after 60 minutes. So the minutes, that part of it, that's our X value. We're gonna end up plugging that in. The fourth part that's important to remember is what is it asking us to round to? So it says the nearest tenth, it's not spelled out as T-E-N-T-H, it's just they put the number 10th of a gram, okay? So the nearest 10th. All right, so it will change based on what it's asking for. All right, so example number 3. All right, so what we're doing is we're gonna find an equation use the equation to figure out how much is left, all right? So what we want to do first, though, is we know the A, we know our X, because remember, we're going to plug into this equation here. All right, and we're looking for the Y. We know our A, we know our X, but we don't know B. So we got to find that first. So every time you do these problems, you got to look for A and for B. And we're going to use that percent to figure that out. Now, what's important is you got to remember to note that we are dealing with a decay. Okay, pay attention to the words of the problem. The words of the problem are going to tell you what type of problem we're dealing with. So if it's the decay, first thing we got to do is let's convert it to a percent. So 28.6, sorry, not a percent, we're actually convert it to a decimal. Okay, we're going to go from percent to decimal. And basically to do a decimal, you do the opposite of trying to go to a percent. So a percent, we go to the right 2. If we're going to go back to decimal, we just go 1 to left 2. So now the percent or the decimal would be 0.286. So basically I went 1, 2, and then I just put a 0 here. It's a placeholder. It doesn't mean anything. All right. You don't actually have to put that there. Now to find the B, since it's decay, we're going to subtract this number from 1. So that's an important part of this. You need to know what we're dealing with. So because this is decay, we need to subtract. All right, so then that means our B, after we subtract, 1 minus 0.286, 0.714. So there's our B value. All right, so that's the first part. Let's put a little divider there. So now I'm going to take that B value, and it's going right into our equation. All right, so the A, 490. The B, this guy down here. So I'm going to put it in highlighter here. 0.714. And then our X, that number right there, is going to be this guy. So that's our time. Usually it's some kind of like time. Like it has to do with like the value of time, okay? All right, and I will come back. I'll pause for a second after I finish this problem. So I'm going to use Desmos to set this up. It's definitely the easiest thing to use to set this up. You could actually do this in Delta Math. And actually, matter of fact, let's do Delta Math because literally it's just like it. In order to do Delta Math, go to the calculator up here, which I think they use Desmos in here. So we're doing 490. Oops, yeah, it's over here to the left. Times 0.714. And then I'm going to use that same A to the B button, and I'm going to put the 16 there. And you can see over here to the right, there's our value, 2.23. But remember, it asked us to round to the nearest 10th. So I'm going to write down, since the 10th is the first number after the decimal, I'm going to write down one more to figure out what I need to round to. So then this is equal to 2.23. Now, right in the nearest 10th, I'll say one number after. When I say after, I mean after the decimal. That means this guy is what we're rounding to, which means I need to look at the number next to it. That is not 5 or bigger. So then I would write 2.2 grams. So after 16 minutes, whatever this element is, we only got 2.2 grams of it left. After, I don't know why we have 2.2, but whatever the case, it just kind of disintegrated, all right? So that's your answer, 2.2. So I'm going to plug that in. Hopefully we get that right. Beautiful. All right. Okay, so I'm gonna go ahead and. So the next one. All right, it says $6,700 is placed in an account, like a bank account, with an annual interest rate of 8%. How much will be in the account after 24 years of sitting in the bank? Round to the nearest cent. All right, so let's write all this stuff down. So 6,000. We're starting with $6,700. We have an interest rate of an amazing interest rate, actually. That's actually quite high. An 8% interest rate. And then we want to know how much money will be in there after 24 years. And remember, this is our X value. And it wants us to round to the nearest cent. All right, so we got to use all that info to figure out what's the next step there. Let me put something down to hold that corner down. All right, so again, first we want to know what kind of growth do we have? Is this increasing or decreasing? Well, we're dealing with interest. When you put money in a bank, interest is how much money you're getting every year. So you get like a percent increase. All right, so interest means increase. All right, so this is growth. All right, that's important to know when we do the B. All right, so now I'm going to find the B. And first, again, just like here, we got to convert the percent to a decimal. Now, if you guys remember, I need to move to the left 2 spaces. I'm going to move left 2 spaces when I'm going from percent back to decimal. So here I'm going, here, I start on the right of the number. I go 1, 2. Now notice I skipped the space. There's nothing there. Like here when I went to, there was a number in that space, so I didn't have to add anything extra. But because I got an open space, I got to include a 0 there. All right, so now my converted decimal is 0.08. All right, so now this is growth this time. So instead of subtracting that number from 1, I need to add that to 1. Okay, and again, we're adding it because it's growth. And here we had to subtract. So when you add, it's pretty easy. You just add that to the 1, so now it's 1.08. There's our B. All right, so let me just do a little divider. We'll do our other work on this side. Now let's set up the equation. All right, so we want to know how much money after 24 years. Okay, so if you guys remember when we deal with money, I don't know if you guys remember, but this, when we're dealing with money, is called the principal. I'm going to add that in there, principal. All right, so now I'm going to start with my A. That's our starting value. And then we plug in our B. $1.08. And then we plug in our X, which is the 24 years. All right. And then we're going to need to plug that in and round it. So I'm going to use Desmond's calculator this time. So 1.08. And then I'm going to click out here. So make sure I can put the exponent on the outside of the parentheses. Put 24. And I get $42,485.91 or 0.910. All right, let's write that down. Now, before I do, I have to round to the nearest cent. This is 2 numbers. after. Because remember, cents you would do to the nearest hundredth. So really what cents is a hundredth. It's the next place after the 10th. So I would run around that to the nearest hundredth is what that's asking for. So I'm going to write down 42,485.910. So again, the hundredth is the second number after the decimal there, which means I'm going to look at that number. The 0 will not change the 1. So now this is 42,485.91 segundos. Wait, that's probably not even the cents, is it? That was terrible. Why did I say that? Growth. And which one is decay? All right, so a town population of 14,000 has a population of 14,000 and grows at 3% every year. So that's pretty simple. It literally says grows, right? So if it grows, well, then that means you're going to add. So when you set up your B value here, you can see that they did 1 plus the 3%, which was converted, as you see there, to 0.03. Because again, what they're doing here, and you guys don't have to take notes on this, we're kind of just reviewing. They're going 1, 2, and remember you got to include that 0 right there, so that's where that extra 0 comes in. Okay. All right, so let's zoom out here. All right, now this one says round to the nearest whole number. And if you guys think about it, it's talking about population, right? We're talking about people. So like, I think what I like about this problem is it makes you think of why you round. Like, why would you round to the nearest cent? Why would you round to the nearest tenth? Why would you round to the nearest whole number? It depends on the situation. If we're talking about people, you wouldn't round to the nearest tenth. We don't have 0.3 of a person. That's kind of gross, right? That's like taking a third of a person and say, oh, sorry, I got to cut you in a third and then, you know, you're included. Like, no, we want like whole number people, okay? So we're going to round to the nearest whole number. So as they go through this problem and they set up their problem, here's what they got. All right, they set up their A value, their B value, and then here's the number pre-rounded or not rounded. And remember, whole number means that we're going to not have any numbers after the decimal. So that means we're going to stop here, right after the, or right before the decimal, right? Which means I just look at the next number, just like I did if it was a tenth or a hundredth. Well, that 2 doesn't change the 6, so it stays the same, okay? All right, let's look at another one. All right, so let's see. Okay, that's another one where you're growing. Let's see what the rounding looks like here. Here's a good example. All right, so rounding, I'm kind of just jumping down to the roundings, whole number. Here, we're stopping at the 5, we're looking at the 8. The 8 will convert that 5 to a 6. So that's why that's a 6 there. All right, this is another population problem, so we're growing again. Decays, so it's kind of like the problem we just did. So I'm gonna pass on that one. Oh, here's a good one. So a new car is purchased for $18,400. That's an okay price. I wouldn't buy it for that much. But anyways, the value of a car depreciates at 10.75% per year. So literally, after you bought the car, after you drive off the lot, after buying it, it's going to depreciate a lot instantly. All right. So basically, as soon as you buy it, cars aren't worth as much anymore. All right. This says 10.75%. So you can see here that we are going to have to convert the percent first. So we go 1, 2, and you can see that now we have our decimal here, and I include every number after the decimal. So 1075. And remember, it says depreciates. So we're losing value. When it says appreciate, like you appreciate somebody, right? That's a good thing, right? That's a positive when you appreciate. So appreciate, if you see appreciates, meaning something increases in value, then you would be adding. But if it depreciates, then it's decreasing. So like think about decrease, depreciate. So those letters DE, that means something's going down, right? So, okay. So now we subtracted, there's our B value. Let's see what they rounded. Let's see what the rounding says. Round to the nearest cent, right? So we did a problem where we had to do cents. So here, that means the 100th, which means these two numbers. But then I look to the right, the 5 will increase that 7 to an 8, and we get 0.38. Okay, we're going to write some of these words down as we go here. So let's, okay, you can put this on the next page, or you can kind of put this on the side. Okay, so if you see, what were some of the words we see? Interest. That's going to be growth. Okay, actually what we'll do is we'll put all the growth words on the left, and then depreciate. I'm just going to put like minus sign, okay, knowing that it's something that's instead of writing the word. All right. Decay, which we should all know that one by now. Or decrease. You see they all start with DE. All right, let's see another one. Depreciates, there's another one. Interest rate, so we saw that. Depreciates. Just want to see if there's any extra special ones here. Decay, depreciate, grows, interest, decays. Okay, so it looks like those are pretty much all the words that you're going to see. Sorry I'm going so fast. I'm just trying to see if there's anything different. All right, yeah, so it looks like that's all you're really going to run into for that particular problem. What you guys are going to get is in the worksheet, you're going to see a graph. And from that graph, you have to interpret it to figure out different key points of information and come up with the equation. All right. So it'll look something like this, right? It's going to give you just a little bit of information. So I'm going to make a quick sketch. It doesn't matter. It doesn't have to be perfect. It doesn't have to line up with your lines. It's just kind of going to go like this, okay? And then you have a point here to make an X and a Y axis, and a point right here in the middle. And then you're going to have another point right here, a little higher up on the line. Okay. So now what you need to know is this first point. And most of the problems are going to give you that first point. So let's just say this is 0 and 7. Okay. Now it starts with 7. And let's say that from here to here, there's an increase of 1 going to the right. And then when we go up, there's an increase of 14. All right, and it's going to ask you, what is that point now? If I go over to the one right and then up 14, what is the new point? I want you to think about that. If I go to the right 1, well, that means X is increasing. We're adding to X. So this is the X increase. And if I'm adding 1, well, that means from that point on the graph, I'm adding 1, so that's just 1. And then this part right there is a Y increase. We're going up. Y increase. So the Y, we're going from 7 and adding 14. So now that would be 21. So there's the next point. So really all you're doing is you're just taking that, add it to the X, which is 0, and then take that and add it to your Y. So 7 plus 14, okay? Now, some of the questions it'll ask you. It'll ask for y-intercept. Let's say, what is the y-intercept? Okay, well, in this case, the y-intercept is 0, 7. Okay, then it'll ask you what's the a value. Well, the a is just the y value of the y-intercept. They are the same thing. Okay, then it'll ask you for the b value, which you're going to have to do a little bit more work to find that. So what I'm going to do is I'm going to take these 2 points, okay, and I'm just going to throw them into a table just so that it's a little easier to kind of visualize or see. All right, so I'm going to take that 0, 7, plug it in right here, and then 121. Now, we're going from this point to this point. Now, again, if you guys remember table to equation, anywhere you see x equals 0, that was your a. And then we're figuring out, what do I multiply? Because again, that's the key thing here, you're multiplying. What do I multiply to get from 7 to 21? Well, I would multiply 3, which is my b value. Okay, or what you could do is take this number divided by the one before, 21 divided by 7, and I'll give you 3. All right, so I know that the a is 7, and the b is 3. So there's my equation. Okay, I have 7 times 3, and then I always want to raise it to the x. All right, so that's how you interpret those graphs. You need to figure out what are those 2 points, and then figure out how do I get from that y value 7 to that next y value. All right. No, I sure didn't record that. All right, if you guys that are watching this recording, I apologize, I didn't record this, but here's the two points that I got from Delta Math. This is the week 7D assignment. So 0, 8 and 228 are the 2 points you need to use to find the equation. I took the 8, which is your a value. I plugged in here. This is your x value, which I'm going to plug into that little x up there. And that's my y, which I plug into the y. So you can see I set it up right here. And then I divided by 8 on both sides. And then I square rooted both sides to get the b value. All right, so here's our problem we're working on, 0, 5, 10, and 10, and 5,120. So remember, from the point that has 0, that's your a. So a equals 5. Okay, so now when I set up my equation, I plug in the 5 for the a, and then you can know that we're looking for the b. And now this is x and this is y. So that y will go right in front because the equation starts with y. So I basically will plug in 5,120 here. And then for the x, that the exponent up here, I'm going to put the 10. Okay? So basically the x value goes to your x, the y goes to the y. All right, so now same steps as before. I'm going to divide the 5 from this side first, kind of like I did divide the 8 down here. See if I can get a little better view so I can include everything in case you guys are still catching up. Okay, so now divide this by 5. So let me use the calculator for that. 5,120 divided by 5. I get 1,124. That cancels. And now I have b to the 10th. So like I emphasized over here, remember we were square rooting because it's b to the 2. Now it's b to the 10. So we're still going to find the root, but now it's not the square root, it's the 10th root. The 10th root. All right, so a couple different ways you can do this on using a calculator, by the way. So again, we've got to emphasize here that I got that 10. Let me just kind of highlight that to make sure that we're doing the 10th root and not just plug it in square root. All right, because I don't want you guys to get frustrated and now all you're doing is square root for everything and you're getting it wrong. All right, so here, when I plug that in, I'm going to first show you guys on a calculator on your phone. All right, so iPhone, Android, you got to flip it. And what I would do is, if you guys notice, sorry, that root, you have square root, you have cube root, and then you have a root that just has like an option, like you can change the number wherever you want. Okay, so what we're going to do is we're going to type, first we're going to type our number, which is 1024. And then we hit that root number, or the root, the one that says root of x to the y. And now what it's waiting for you to do is tell it what is the root. Well, it's 10. And after I do that, I hit equals, and there's my answer, 2. That's one way to do it on your phone calculator. A lot of times, different calculators have that same option. So if you're in class, you guys ever, when you guys do come back to class on this calculator, you can see that option's right there. You'd have to hit the second button, then this one. So some of you guys might have a calculator at home that has that option on it. You basically would hit that first. And on this one, what you have to do is 10. You actually have to hit the root first. And then you go second to get anything that's in that color, because it's blue. And you can see it shows up there. And then I put the number inside the root after it. Okay. Now, easiest thing for you guys to use, Desmos. All right. I'm just showing you guys different ways to do it in case you're stuck in a pinch or whatever, and you have to do it a different way. Desmos, you can see that option right there. It's an N instead of an X or a Y. And you just put the 10 there, and then you put your number inside. And then that's how you guys can calculate it that way too. Okay. So 3, 4, 5 different ways. Even Delta Math, I think, has that same calculator. Okay. On how to do that. Okay.